we chose a fixed value here. Okay, that -5 is a fixed value. The alternative to a fixed value is a variable value, meaning that it could be anything as long as it fits within the parameter of this X field can't receive the word blue, right? Because blue makes no sense in terms of a numeric value. There are really like 3 or 4 different kinds of variable values that we're going to encounter on a regular basis starting now that we need to take into account. The first one that we're going to encounter is a float. And a float is short for floating point. I mentioned that a little bit earlier. And all that means is that it's a value, it's a numeric value with a decimal point in it. Okay, so when we encounter a float value, it could be something like 0.1. It could be 1.47. It could be 100, because implied in that is 0.0. It could be negative 56.8743. Those are all legitimate float values. Okay? That's pretty common. And the place where we see float values pretty regularly are in the position, rotation, those kinds of things. We're going to encounter a couple of other variables, but the idea of a variable is that there's different data types. So a floating point is something with a decimal point. An int is short for integer, or a number. It's a whole number, which is different than a float. So we can have 1, we could have 100, -47, but we can't have 42.1, okay? That's incompatible data type. An integer cannot have a point included in it. A float, we talked about, could look like a whole number, okay? But it's implied that it's there. So floats are a little bit more flexible in terms of what they can do. Integers are a little bit more efficient. And a string value. Has anyone encountered the term string before? String is just a bit of text, alphanumeric text. It's when you're playing Fallout 76 and it asks you for your player name and you type it in, that's a string value, variable that you're entering into that field. Okay, when you win the high score on Dance Dance Revolution in the arcade and it asks you for your initials, it's a string value that you're inputting. Okay, this is any alphanumeric information. It could be something like Lance. It could be something like hello. And we can't perform logical math on a string. Okay, we can do some funny things with strings. We can apply some math to floats and we can apply math to integers, but we can't apply math. We can't say hello plus 1 equals something. Okay, but we can say 1 plus 100 equals something, or minus or multiply or whatever. Okay, so these are like some basic data types. The basic concept of a variable, the metaphor it's often used is a container, okay, like a cup, a vessel. We create variables that are containers, okay, and we give it a name. I'm going to call this cup. And inside cup, I determine that this cup is either a float cup, an int cup, or a string cup, okay? And when I declare what kind of cup it is, it holds that kind of data. I could put anything in this cup, okay? If I put a red cube in here and it's string data that I'm looking for, it would probably be red or cube, okay? If it was an int, what's in my cup? What's that whole number? 1. There's 1 cube in here, right? If these cubes represent health, and I have 10 health or 100 health, okay, and this cup is called health, and I'm using floats, and I have 10 cubes in here out of 100, what's the percentage of my health that's in my cup? 10%. So my health is low if my scale is 10. 100. If my scale is 10 and I have 10 health in here, what is my health percentage? 100. Okay. Now, whenever we deal with percents, 9 times out of 10, when in doubt, when you're dealing with a number, go with float. Okay. We're going to start building our first variables, and we're going to do this by going back to our paddle for a moment. So the way that our paddle works is that we can go left and we can go right. So we're influencing this x value, right? And if we go left, we want a negative value. And if we go right, we want a positive value. We happen to use 5, okay? But what happens if our game requires that our paddle moves faster or slower based on a power-up? Okay, if we hardwire this value in, we're stuck at 5. The only way the user is going to get a different paddle speed is if they can crack our game, get inside that data, reprogram it, and say, no, I really want my paddle to move at 7. We can provide the user with the ability to change that, but as the game designer, we want to say, no, this should be equivalent to your health. If you start on a scale of 10 health, as your health goes down, maybe this value goes down. Or maybe it's, I pick up this star and for 30 seconds, I get to move twice the speed that I'm currently moving at. So I move at 10 and negative 10, okay? So we want to be able to change this. And so what we're going to do is we're going to establish a variable that we can use, and we'll call it player movement. Now, we're going to create variables a pretty straightforward way. If we roll over the label of a value, it'll tell us what data type it is. An x value, because it has to do with the transform, is a floating point. It tells us it's a float if we roll over it. If we roll over the game object, it'll tell us the type is a game object. That's another kind of variable. There's lots of different stuff in here. What we want to do is to be able to use one value that reflects this speed. So what we're going to do is we are going to create a player speed. So I'm going to toggle this little equal sign to where we have a drop-down menu instead of a hard value. And I'm going to click and create a new variable. Now, when we create a new variable, just notice that there's a variable tab also, and we could create a variable by going to the variable tab, typing in the name, and then choosing the variable type. These are all the different types of variables that we can create. If we create it this way, we need to create an appropriate data type for the field that we're using. So in this case, we would need to use a float, but I'm going to go back to my state. Because I'm using this drop-down menu, and I say a new variable, it's going to make a variable based on the data type that we need, so we don't have to really be too concerned about it. It is helpful to know what kind of data it is, because we can use it for different things, and we can start to see the connection between all the different variables in our game. So I'm going to create a new variable, and I'm going to call this player speed. Now, player speed, when we're creating variables, there's some really, really important rules. In fact, last week a student's game broke because they named their variable wrong, and it was simply, it felt logical, but there's a couple of rules. Only use letters. You can use numbers as well, but you don't want to start with a number. Always start with a letter. It should always start with a lowercase letter, and it should not include spaces. Okay, so a variable should always start lowercase and should not include spaces in the name. You'll see some variables that, where people put spaces in and it works okay. The reason that we use lowercase is that we might type in the name of a function that Unity needs, and functions use capital letters. And so if we typed in something inadvertently that Unity needs behind the scenes, it could interpret that as calling a function instead of using a variable. So lowercase rules that out. Spaces can be interpreted kind of funny, so we want to exclude any spaces. I'm using a capital letter to distinguish one word from another. That's called a camelback casing. We can use that, or we can use an underscore. Okay, so right now I've created a variable called player speed. I could also wipe out that S, use a shift minus or an underscore, and use player speed. That would work too. I get that visual break, I'll hit return, and now I see that there's a variable that's being used instead of a number. Okay, when we use a variable, we need to know what that container is holding. Okay, and by default, it's nothing. In the case of a number, it's 0. Okay, and I can validate this, and from now on, we always want to turn on this debug check mark down here at the bottom. What this debug check mark is going to do is it's going to show us, if there's a variable, what its current value is. So you can see this little gray bar pops up under the X. That's showing me what my current value, you got a mouse out of here, of player speed is. It's currently set to 0. Okay? So there's really 2 ways that I can change the default value. There's 3 ways, mainly. I want a starting value that's a little bit different. And I'm going to choose a number that we can change. I don't want it to be 0. Okay? And the easiest way to get a starting value for a variable is to go to the Variables tab. To identify, I now have one variable listed here, and if I select it, I can go down here. This is where I'd rename it if I had a funny name. And the value, I'm going to highlight 0, and I'm going to change it to 3 for now. So it's not 5 and it's not 0. It's a different value than I started with. I'm going to go back to my state, and now you can see that the value of player speed is currently 3. Okay? So this might feel a little strange, a little abstract, a little redundant, but instead of saying move 5 or -5, we're saying move player speed. Player speed is our container, which we can feed anything into it that we want dynamically. Okay, so we've just fed a value of +3 into this field. We're going to have a major bug here in a moment. Okay, because the goal of this is that we want to be able to use player speed for both go left and go right, but we have to take into account that it's a positive and a negative. Okay, right now if I hit the play button, I didn't change my go left. If I hold down the left key, I'm moving -5. If I hold down the right key, you can see that I'm moving +3. So I'll eventually move back. So I move a little bit slower to the right than I do the left. The right key is using the variable. Okay? All with me? Okay. So we're starting with a positive value and we're using that positive value here. How do we turn a positive value into a negative value mathematically, other than just adding minus in front of it? Mathematically, how would we do that? If I have a 3 and I want to make it a -3, what do I multiply that by? What's the formula? Does anyone remember way back when? -1. So if we kind of go back in time, and I promise you this is not going to be a math class, but there is some basic math that we need to consider. If we take 3 and multiply that by -1, the result is -3. If we have 3 multiplied by 1, that would equal 3. Okay? We could also get to -3 if we took 3 and subtracted 6, but if this formula holds up, if that is 3 or if it's 20, if we multiply that by -1, it becomes -20. If we multiply it by +1, it becomes positive. In this case, if it's positive, it ends up positive. If we have -20, now it gets tricky, what do we multiply it by to get +20? Another negative. Okay, so we know the formula. We're not going to have to go that deep into it, but we can manipulate the positive and negative number by running it through a positive or a negative equation. So here's what we're going to do. What if, when we ended up in the go left state where we need a negative value, every time we end up in this state, we flip it from its default positive value to a negative value? What would we do? Just what do we describe up on stage there on the screen? want to take our positive 3 and convert it to a negative 3. What will we do? Multiply it by negative 1. We take our player speed multiplied by negative 1 will give us this result that we want. Okay? So what we can do is we'll say, there's a little math function in here, which is kind of fun. We can go into math, and you'll see that we have all of these operators. Okay, and what we can do is we can do a float absolute, a float add, float, 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 all these things. I'm looking simply for a float multiply. Okay, and I'm going to do this on the left, meaning that every time we end up on the left, I'm going to do a float multiply. I'm going to move this up in the stack here so we can see this a little bit more clearly. And I'm going to take what float value do we want to use from our list of options here? Can we see this? Player speed. And we have positive 3, but we want to convert it to a negative, and so we determined that we're going to multiply this by negative 1. Okay? We don't want to do this every frame. We just want to do it one time to convert that value, whatever this positive is, this player speed, we want to convert it. Okay? So what the float multiply is saying is take the value of player speed and basically invert it. In this case, to negative. Okay, so what we want to do down here in our translate is not use a hard value. We want to use the result of player speed. So I'm going to toggle this equal sign. I'm going to click on the drop-down menu, and I'm going to use player speed. Okay, so all we're doing, that might have been a little abstract, but all we're doing is we're establishing a value for player speed. And then when we enter the go left, we're going to multiply it to negative 1 first to invert it. Okay. I have my debug turned on, and I can test this. What I'm looking for is that when we end up in the go left, I want to verify that this number becomes a negative. I'll have another bug which I'll need to fix, which I'll show you, but I'll hit the play button. I'm going to hold down the left key, and you can see that because we're using player speed, it just works out. We've taken player speed and multiplied against negative 1, meaning that we're updating the value of player speed. In fact, we should be able to go over here and see what, if we select it, we can see what our current value. This is a variable value, meaning that we're changing it based on user input in this case, right? So our default value, when we hit the play button, we determined that our starting value was 3. But if we end up in the left state, we multiply that against negative 1. Okay? Based on this list of actions, does anything jump out at you about how we could reset this back to a positive value? Float. Let's just look at the float. We can float absolute, float add, float multiply, or add multiple, excuse me, plan divide. Some of these are a little obscure. Our gut might tell us, well, if we multiplied it by negative over here, if we got a negative coming in, we could correct for that by multiplying against a negative, but what if it comes in as a positive? So in other words, the first time that we go to the right, that value is already a positive. If it comes in as a negative, we want to make sure it's a positive, and if it comes in as a positive, we want to make sure it's a positive. Does anyone remember what absolute value of a number means? What's the absolute value of negative 5? Last math question for the day. 5. The absolute value drops the negative, right? And I saw in here that there is a float absolute, and this, so we could use this. There's other ways that we could do this, but I'm just kind of going with the basic logic here. I'm going to go float absolute. I'm going to make sure, so I'm moving this up above the translate, okay? And the reason I'm doing that is because by the time, so actions run from the top down. There's an order of operation. When it gets to this state, it'll loop and keep running it, but it runs from the top down. And by having our absolute down at the bottom, it would actually run for 1 frame or a couple frames before it gets to the absolute and switch, so it might get a jump one way before it starts going back the other way. So that's why I'm making it the float absolute, making sure it's showing up somewhere at the top of the stack. I'm just going to set my player speed to absolute. That'll ensure that when we go to the right side, it's positive. And as it comes into the left, it's always going to be, not always, we still have another bug here that we're going to have to accommodate. Okay. I'll hit the play button. I can go to the right. I can go to the left. Feels like it works pretty good. I hit the left button again. I'm using 1 button. Why might that be happening? I'm hitting the same button, I promise. Let's walk through the logic here. We're starting out in idle. What's our player speed at idle?
0.
It was 0 until we gave it a default value. We gave it a default value of 3. So that means that when this variable appears, and we're going to do this another way in a second, we're going to establish that value in a more logical way. But basically we said the starting value, the default value is 3. Okay? So when we hit play, we pass through the start state. We end up in idle with our player speed set to positive 3. Okay? We go right, what happens? We end up over in the right state. What happens to player speed based on our logic? What does it do? What's the function that's being provided here? What does this say? Float what? Float absolute. So that means that if we're starting out at 3, being very literal here, if we're starting out at 3 and we come over here, we're taking 3 and making it absolute 3, and then using it down here to move. What is now our move value of player speed? Positive or negative 3? What's that? Positive. Right? So positive 3 comes in here. It gets a float absolute, meaning that it's positive, it's already positive. Float absolute will not invert it, it just says positive value. So we're certain it's being used here. Let's go through this again. We're at positive 3. We come over to go left. We're at positive 3. That's our player speed. Here it is. We multiply it against negative 1. What does that make our player speed? What's that? Negative 3, so we use it here. We release our left key, it resets. What's our player speed when we get back here from left? What's player speed still? Negative 3. We haven't changed it. We haven't done anything. So now we hit the left key again. What's negative 3 times negative 1? Positive 3. So if we're going left, 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 we're inverting each time, so we have a bug. What's one way that we might fix that bug? What would we do on idle to ensure that our speed always ends up positive? What do we do over here to ensure that it's always positive? Yep. This would be more appropriate. I'm going to Command C to copy this. I'm going to go to idle, I'll right click and paste action. Float absolute. So I'm always starting out, I'll go to my go right. This is not the appropriate place for this. The logic was there, it did what I wanted it to do. I'm going to delete this. I can highlight the label and hit the delete key, or I can click on the cog here and say remove action. Either one of those will get rid of that. Alternatively, I could have kept the action and just deactivated it with the check mark, but that just kind of keeps a little bit of clutter. So in this case, what we have is that every time we go back to idle, our player speed is whatever our absolute value is. It's 3. It's here, it's still 3. It's here, it's 3. Here, it gets multiplied by negative 1 and becomes negative 3. Okay? The only glitch we would have is if we go straight from left to right, which is something that we you know, we'll talk about, there's a more appropriate way to do that, but this is a good kind of logic problem to solve. So we've kind of fixed that, okay? Let's do one last thing, which is, this is going to be a very common thing that we're going to see. We want to create an initialization state for our game object. Okay, this is our paddle controller. And typically what we want to do with a game object, like a player, is that we don't want to go from start into our core mechanic. What we probably want to do in this case is go from start into an init initialization. So we want to initialize some values, and then we automatically want to, what we'll do is we'll do a finished event, which automatically says whenever this is done, whatever it's doing, we're going to then pass it over to, okay, so we're going to take the start state, attach it to an initialization state, and what we're saying is when this game object comes alive, when it comes into being, when our game starts, it's going to pass through initialization before it goes over here. We're going to use initialization to establish our starting player speed. Even though we did it over here, this is not the most appropriate way. We can do it that way, but we want to initialize our speed value here. We can also initialize health, ammo, position, any kind of stage or milestone. There's a lot of things that ultimately in game design we'd want to initialize. The current state of our player, the starting state of our player. Usually in games we have a basic health system. We might have some ammo if it's a projectile-based game. We might want to, be considerate of what's our starting position. In this case, it's simply player speed for now. Player speed. We'll initialize that. Meaning that if we change it over time, whenever we restart our game, it's always going to be that starting state. Which is not the case if we leave it over here. Okay? We don't want to initialize it in the idle state, even though that might logically make sense. We don't want to do that because if we change it, every time we end up back in idle, it's going to reinitialize back. Okay? So here's how we do this. It's more complicated to explain it than to do it. I'm going to right click and add a state. This state, I'm going to rename it init. So whenever we see an init, we know that that should be the first state that it passes through, and we know that it's setting some basic parameters. With that init state selected, I'm going to go into the same math category. Not only can I add, multiply, and do all this stuff, but I can set a value, and it's a float that we want to tinker with. So I'm going to set a float value. The float value that I want to set is player speed, and I want to set the player speed to 8. I'll do 8 for now. Okay, that's my initial starting speed. Okay. Now I'm going to right click. I'm going to set this as the start state. Start goes over there. Okay. I'm also going to right click, add a transition. I don't want to use left, reset, or right. There's a special transition in here called a finish transition, which is very useful. I'm going to set finished, and I'm going to wire that over to idle. What all finished says is when it's done running, whatever action, sorry I didn't have that projector down, I didn't realize that it would have been so hard to look at up here. What the finished state says is that whatever actions are listed here, they're going to run through one time, and when they're done, exit the state. Okay? So here's how this is going to work. I'm going to toggle the play button. We're going to pass through the init state. It happens so fast we don't even see it, but we know that the logic carried us through. It's rendering our current value of player speed, which is now 8, which is different than we set it over here, and it's different than 0, so we know it's working, right? And now as long as we have the rest of our logic works out, it feels very complicated just to get something to move back and forth, right? We've been at it for like 15 minutes now. But I hold down right and left, okay? And now I'm moving accordingly, okay? And the nice thing about this is I can go to my variable. I should be able to change this. I'll change it to 15. And you can see my speed is now 15. I'm doing that on the fly. I'm kind of like giving this just a little hack. Change it to 30. Now it's even faster. Okay? Which means we wouldn't change the value this way, but I might say, okay, the longer time lasts, slowly add the speed so it gets more complicated. Or maybe, again, I pick up a star or a rocket, a little rocket icon, and now for X amount of time, my player speed equals 30 instead of 8. Okay? But I've changed that value to 30. I'm going to toggle the play button. I'm going to toggle the play button one more time. What's my player speed? 8. Because we reinitialized it. Okay? If we set this through, if we just kept resetting this variable, it would remember what that variable is. All. Okay? So now I have this basic player speed. Okay? I know it seems super complicated just to get this thing moved left and right, but we kind of slowed down a little bit to talk about variables, and variables become super important because variables are the key to all interactivity when it comes to games. I have a player, my health is 5 and it should be 10. The only way I'm going to get health is if I pick up the health kit or the band-aid or whatever it is. So I'm going to take my health plus 5 plus 10. Or I'm going to take my health and multiply it by a percentage, okay? Or I'm going to stand on this thing, I'm going to take my health, I'm going to add 1 per second. My health is 6, it's 7, I get off this thing, it's at 7. It's at 8, it's at 9, someone's shooting at me, I better move. My health stops increasing. I get hit with a bullet, it's -1 to my health, okay? That's, kind of a core example of how we're going to use variables. Have a health system that's being managed. It's going to determine whether we pick up something that's good or get hit by something that's bad. We'll do that in the next, we'll do a little bit of that here with the bricks. You can see my sphere keeps bouncing higher and higher. Okay? Any questions about that stuff? I don't want to pile on any more for today. That was like as much of the technical stuff. We have a couple of requirements that we need to, that we're eventually going to need to address.